Okay, so 15.1 magnetic fields. So you've already done a fair bit on magnets, and you know that if you put two north poles near each other, they'll repel, and if you put two south poles near each other, they'll repel. But if you put a north and a south near each other, then they'll attract to each other. Okay, bit like electrons and protons. Okay, that's what you know already. So let's go in a bit more about how we represent that, because it's the fields bit of this that gets people confused. Okay, so first up, you've got your bar magnet. Now, when you're drawing a bar magnet, there's a couple of things you need to know about the field lines. Okay, so the field lines always complete a circuit, like so. And if you put the arrows on the field lines, you will know which end of the magnet this is. Okay, so, and all they do is go out in bigger and bigger circles. Now, sometimes we draw these going off into infinity like this, but all they are is bigger circles than what we can fit on the page, so don't worry about them too much. They do go around in circles, it's just a representation. Okay, so the next thing we need to know is which one's north and which one's south. Well, the thing with these arrows is these arrows always point the same way. You always start at the north and the arrows go to the south. So if you look at my circle here, started at the north and I went all the way around to the south. Okay, so you go from north to south. That's the way you draw your arrows. That's what those arrows are for. Now you don't go on the other side, you don't go from south to north. No, still north to south. It doesn't matter which circle it is, it's always north to south. Okay, so you would be able to know how to draw your field lines if you're given which one was the north pole and the south pole, and you'll be able to tell which one was the north pole and south pole if you're given the field lines. Okay, so that's the two things you need to know. The next thing you need to know is that the closer together the field lines are, the stronger the magnetic field. So if you look, if I put down like if you imagine I have a square that's this big, okay, and I place this square that's this big here, you can see that I'm covering two field lines. Whereas if I put that same square that's that big and I put it here, look how many field lines I'm covering here. 1, 2, 3, 4, 5, 6. So this bit here is 3 times stronger than this bit here. The magnetic field is 3 times stronger here than it is here, because I'm cutting through 3 times more lines. So 6 here and then 2 here. So how close together the field lines are, that represents how strong the magnetic field is. Okay. So the next thing you need to know about is how do those magnetic fields interact with each other. Okay, so if you look at, say, for example, if this one has two north poles, what happens is, okay, so you end up with something that looks like that, because it will still go. So what you're doing is you're squishing these circles together, so you're squishing them around the corner. It'll still go from north to south, just like it did the first time in the first picture. So we draw our arrows from north to south. This one's still going to go from north to south. But the thing is, the field gets pushed together, so the actual field lines get affected by each other, because the magnetic field in those places gets affected by the other magnet, and leaves you with this gap here where these two don't meet. Okay, and the magnetic fields cancel each other out, sort of. Okay, so the next one. Let's look at the converse of that. If we were to turn one of my magnets around here. Sorry, I've drawn it too close to the other one. I'm going to move this a little bit further, just so it's not confusing. So if I go south, north, this time it starts to north and it'll go to a south. The arrows will go like this, you see. Okay. I mean, they'll still do this as well. It is still a magnet after all. Okay. Starting at the north, going to the south every time. You can see here, these are lots and lots close together, so therefore the magnetic field there is really strong. So we can start start to figure out how, by knowing that rule that it always goes from north to south, you can start to draw these more complicated diagrams. And that's it. That's literally the rule that there is. Okay. The other thing that you need to know is that you can turn something that is not a magnet into a magnet by stroking it, or as we're in Bristol, smoothing it with another magnet. And the best explanation of this that I've seen is on Veritasium, and I've put that on our Edmodo. So if you look at the Veritasium video on Edmodo, it explains a lot. It explains really well about permanent magnets. Okay, it really does explain it well. Really good video. So I recommend going to the Edmodo class and looking at that Veritasium video on permanent magnets.